thank you everyone for joining us today for our office hour, all about real world performance. Today we have with us our very own senior professional services engineer, Grayson Hicks. Grayson, I know you audited like dozens of Jamstack websites over the past 2 years. He's been able to cut load times in like half, which is hella impressive. And he's able to also deliver performance gains that are quite spectacular, if I must say so myself. So welcome, Grayson. Thank you for offering up your time today, making yourself available to answer everyone's questions. So really appreciate you helping us all out here.
Yeah, happy to be here. I love doing these and sharing, the tips and tricks that we've learned in our experience.
Awesome. So let's just jump right into it. What do you think?
Yeah, let's do it.
Cool.
Well, as Neha said, I'm Grayson Hicks. I guess I'm relatively new at Netlify. I was on the Gatsby team before for a little over 2 years, and Netlify here for like a month. And part of my responsibilities is auditing websites for typically our enterprise size clients, right? So a client might come to us and say, they want help with their Lighthouse score, and they're not sure what's going on. So we'll typically meet, once a week for about a quarter, investigate, then we'll implement the fixes and we'll retest, and then kind of start over again, right? And continue going. A lot of these folks have been with us for 2-3 years, because its performance is an ongoing process, especially as you integrate new features. So I guess I'll go ahead and do the surprise, but like the main thing I'm most excited about is in the last 2 years, this program, which we call Concierge, has been a Gatsby focused offering. Now I want to caveat that with it's almost never like a Gatsby specific solution to performance, right? Performance is really based on the browser. And most meta frameworks like Gatsby or Next or Remix or whatever, they have abstractions on top of these things, but ultimately you need to make the browser happy. So you might need to know a little bit of like, how does Gatsby make an image work better, right? But ultimately it comes down to the fundamentals of the web. So, now that we're with Netlify, an exciting thing is we want to start offering this for any team, right? So if you are a team with building your sites with Next or Remix or whatever, we want to expand this beyond Gatsby because we just found that, most of these recommendations are not Gatsby specific, right? It's just web fundamentals. So that's what I'm most excited about. So at the end of this, if you're interested, I'm not sure what the next steps would be for that, Neha, but reach out and let us know if you find this useful for your team. And we work with really large teams and not so large teams. So actually one of the success stories I have today is a relatively large law firm, but I'm also in the midst of working for like a Fortune 10 company's performance audit right now as well. So kind of runs the whole spectrum of the size of sites. So I'll talk about one success story. Then we'll just look at some of the main things that we come across: scripts, JavaScript bundles, media, and then lazy loading. And then I also want to touch on like some architectural things that I think are important, right? That are kind of outside of these things. So let's dive in so we have time. I'm a big believer in everybody getting their question answered. So I'll try to move quickly so that all the questions can get through. The slides we have here are based off of past questions that we've seen repeated. So biggest performance challenges you've seen on a professional site, I would say it's a 3. And by that, I mean, I've started with a 3 on Lighthouse score for a large client. They were a 3, like you name it, it was wrong. Unfortunately, that's like not that uncommon, like to see folks start in the single digits on mobile. I typically test pretty hard. Like I'll go with a 10-year-old phone, maybe like a Moto G4 would be pretty hard. But it helps you see issues that maybe if you're on the iPhone 14, you're like, oh, the site's great. It's really not, right? Like so I'll use older devices to make sure that I can actually see problems that people in the real world will face. So And the worst I've seen is probably starting out with the 3, where almost everything was wrong. Number one thing is probably not server-side rendering with React. So there's multiple foot guns with any React framework to accidentally make it a create React app, which, like, not bashing create React app, but there's a time and a place for like a fully client-side rendered app, and it's typically bad for performance. So most common and like biggest thing I see is somebody sending basically an empty div over from the server and then turning that into a React app, like completely client side. It's kind of a no-no for most sites. Biggest wins. Yeah, I mean, we've definitely gotten a couple in the high 90s with marketing scripts, which I would consider a pretty big win.
Awesome.
So I want to talk about Robinson and Henry. So this is the law firm that I mentioned. They're based out of Denver. Wonderful team, not only within the law firm, but they use an agency out of South America. That was a wonderful group of people to work with, and they really knew their stuff. They were coming from a very, very typical story. They were a monolithic CMS, so they used WordPress, pretty old version of WordPress, but like that powers huge swaths of the internet. So that's what they were based off of. But performance was like pretty middle of the road, maybe high 40s, low 50s for, Lighthouse score. And let's see, I think I have their site up here. Here they are, right? So it's not like the simplest website. There's images, there's video, there's a lot of relationships in the data, but it's a very, very snappy look and feel. They're still using WordPress on the back end. So they were able to maintain all their content, all their editing workflows, all that. We just swapped out the front end to use Gatsby in this case. But this went up to the mid 90s, I think. I did not retest it before the webinar, so hopefully they haven't had any regressions. But it was like pretty big improvements for them. And this was like a direct driver to business for them. And that's one thing to always keep in mind with these is, like, why do we even want performance anyways? Like, it's not like just a feather in your cap to say, okay, cool, I built a fast website. These are business decisions, right? You got to pay your engineers to make the site faster, and there should be a return on that investment. So typically it's about, driving, lead generation and conversions, where you want, if you send out an email campaign to a landing page, you want that landing page to load as quickly as possible so that you can get a couple more conversions. For every second or so that it takes to load the site, someone's more likely to click away and go back to checking their other emails, right? So lots of reasons financially that you would want to have good performance. Accessibility is another one. I see performance as a form of accessibility myself. As I mentioned before, I like to test pretty hard on myself when it comes to devices, because it can be easy to live in a bubble, especially as developers with a fancy new laptop and a nice cell phone. But the average user around the world might not be having that experience, right? You might have hardwired, fiber, but other folks might be, walking down into a subway on an older phone and losing their connection, and they still want to have a good experience. So accessibility and finances are two big reasons that I think we should focus on performance.
Awesome. Grayson, I'm just going to interrupt you for a quick
Sure.
second. I see a whole bunch of questions coming in, and I want to make sure we're getting to them. So we have a question here from James. Do you recommend page speed? I found if you let stakeholders use Lighthouse on their potato computers, their results get distorted.
Sure. I could have like a whole 1 hour session on just our testing methodology, which I actually do as part of our program, because it's so important that the dev team can talk to stakeholders in the correct language and say, hey, don't just open up DevTools here and run Lighthouse in your own browser, right? I mean, you can, like, if you want to see how your experience is, but it's important to understand that is your experience in multiple ways. You run a Lighthouse test locally, that's your CPU, your browser, your internet. It's completely tailored to you in that moment in time. That being said, page speed, if you say page speed, like, that kind of encompasses a lot of different things. So Let me open up page speed here. Copy this. All right. I'll do a quick rundown of this, right? So top half of page speed is actually super important, very valuable, and you can take these numbers to the bank, which, all right, maybe not the best, maybe not the best language this week with the banking stuff going on, but you can, these numbers are valuable and considered like the source of truth for your user experience, right? This top half here, which it's kind of like small text, but right here it says the source is the Chrome UX report. This means like every user that's gone to your site over the last 30 days that's opted into data sharing with Chrome, it's recorded their experience and put that up in a database and averaged them all together. So you can see the average user on Robinson and Henry's, all in the green, having a great time. This is what you would want to show your stakeholders and say, you know what, this means the guy walking on the subway, the girl with an M1 Mac, all of those experiences added together would be this top half. Now, this bottom portion here is like me today in this moment, right? So this bottom half is what we said before, kind of running it locally. I think this actually runs it still in a server farm. So again, another kind of difference. So just in 3 minutes, I've explained like page speed could be these 3 different examples. It could be you running it locally, you running page speed like in a server farm like this, or like the aggregation of all the page speed experiences over the last 30 days. On top of this, I like to use web page tests as another tool to kind of deep dive into some of these things. And then you've kind of got this bottom opportunities panel of page speed that I really like. It gives some like plain English kind of things to work on, things to look at outside of just numbers. You're like, oh, well, 155 milliseconds, what do I do? Right? Like if you go down to opportunities, it kind of gives you a checklist of things. So there's lots of tools. They all have their place, but there's not like a silver bullet for this. So should you use page speed? Yes, you should, but there's a lot of nuance there. So yes.
Well said, Grayson.
Yeah.
I do love seeing the accessibility score for Robinson and Henry at 97. That's super impressive. For anyone that's curious to learn more about this, we actually have a case study up on the website that Sam has shared in the link in the chat. Be sure to check out that link for deeper insights into how we achieve those scores. Grayson, we have another question here from Nirmal. She's asking, why is server-side rendering better than client-side?
Okay. So I always hesitate to use the word better. I probably did say that. But there's always nuance. There's always what ifs. So the way I like to think about it is you need to know like what your app is trying to do and who you're trying to serve. The main line I use for client side versus server side rendering is like session length, right? So session length is how long is my user kind of like staying within my app, right? So I like to think of a long session app as something like, maybe like a dashboard app that's got lots of graphs and someone's toggling and they're looking at stock charts and stuff. Like it's almost, and they have maybe a logged in experience, right? It's very, very dynamic. That to me would probably be okay with client side rendering because you're going to be loading some JavaScript up front. You might even get a loading indicator, but then they're going to stay there for a long time. And they've paid that tax once and they're not going to have to pay it again. And it's going to be fine, right? They're not going to have any page reloads because it's going to be client side routing. That's kind of where I would see full client side apps. For things like content heavy sites like blog posts, articles, lots of route changes, that's where server-side rendering, I think, is superior. There's definitely foot guns for server-side rendering as well. But typically, JavaScript is the hardest part, hardest thing for the browser to work with. And you're seeing, I mean, almost all frameworks now default to SSR first. Whether it's React or not, like SSR is considered faster. You can have problems still, and you still need a little bit of client-side JavaScript, but typically we want to go for server-side rendering.
Awesome. Thanks, Grayson. We have a question here from Kevin. How would you audit performance over a full user journey? Most of these tools seem to only judge on just one page, but a typical user will view many pages, we hope.
Yep. Great point. And that's kind of what I was just talking about with session length, right? So you can come up with some real user paths for two different apps and can kind of show where client-side rendering could be superior if they're have these long sessions and these user paths. So web page test does let you kind of script navigations and clicks and such. So I've used web page test for that before, and it will record the whole thing and be like, all right, step one took 3 seconds for initial page load, and then to go to their account and change their avatar, whatever those next two steps took X amount of time, and you can script those things. There are some other tools I've used. GT Metrics I had good experience with, but it's been a little while. But there's, I believe, several tools that allow you to script. Most of them have a free tier. Like Web Page Test is a pretty generous free tier, but they also have paid options to kind of give you some other, more advanced things that you can do. I don't know of a way with page speed to do any kind of scripting. I also typically will take an average of 7 runs. So when I do Web Page Test, you can tell web page test, hey, run this 7 times and then give me the one that's closest to the average.
That's a good point. Cool. We have a question here. What are the best ways to control what gets rendered on the server versus pre-rendered during the build time?
Cool. So this seems a bit like so rendered on the server and pre-rendered on the build time, depends on the context of your framework. So like Gatsby, it's kind of all server-side rendering. I'm not sure that question is like the best way to describe it. Like Gatsby runs its build statically. It runs at like React SSR. So like it's a React server, rendered to string, right? Like that's React server-side rendering, and that happens during Gatsby build. It also would happen during like next, get server data, right? Those things are still happening server side. So whether it's rendered during a build step or rendered like SSR, it's just a matter of timing, right? It's way ahead of time would be build time, and then just in time would be SSR, and then client side would be like, I don't know where you would put that on the scale, but I think the gist of this question gets to the core of what a lot of teams are trying to figure out, which is like, what about this page is very static, and what about it is more dynamic, right? So yeah, you can reduce that time to first byte by reducing the number of things that happen on the server. That's where I said there are pitfalls with SSR, which is if you have a get server data function or get server side props function in Next.js, and you've got a bunch of really expensive calls in there, like that time to first byte's going to take a while, right? Like you're moving the work around, but the work still has to happen. So if you put it all in get server side props, that can take a while. But when you move it client side, you might have some loaders, some spinners. So I typically like to think about how dynamic is the data. Also, you have to think about, what's above the fold. So, things that are above the fold are going to be more important for that performance score and the user experience. So you can use, different strategies, lazy loading and others to load stuff that's below the page as the user gets there. And yeah, that's a very, very in-depth kind of conversation. But yeah, I look at how dynamic data is and then where it is physically on the page.
Thanks, Grayson. I'm going to ask one more question before we continue with your slides. James is wondering, are you using virtualized or physical devices for testing, something like Browser Stack?
It depends. Good question. I prefer tools that offer physical devices. Nowadays, I feel like those are moving towards all paid tiers, possibly like even web page tests, which I love, but I think web page tests kind of pushes you away from that. I have a feeling that's more expensive for those tools to run. But like page speed is going to be virtualized. And that is always a big asterisk for me of like how valuable the data is. So, and what I'm talking about here is, say I do that Moto G4, right? Is there an actual Moto G4 sitting in a closet somewhere that's running this test? I want there to be, right? That way I know that's the actual numbers. The other option is it's actually running in like a server rack somewhere that's a big beefy computer. And then someone like Google will use an algorithm, which I'm sure they know what they're doing, right? But like they basically back it up, right? So they run it full speed from the server. And then they're like, wait, we need to make this look like it was a Moto G4. So they have an algorithm that says like, all right, if this were a Moto G4, it would have actually looked like this, right? So accurate, but like not the real thing. So that is something to consider. Might not necessarily be as accurate as the real thing. And I've seen this illustrated before by someone setting like a set timeout where there's no way the first contentful paint was before 2 seconds, right? They do a set timeout. The page is blank until 2 seconds. But if they run a test with the virtualized device on there, it will show the FCP as like 1 second, which is physically impossible, but the algorithm says that's what it would be. So it's a bit of a contrived example, but it is meant to show like highlight, hey, these are algorithms on the virtualized ones versus the physical devices. So network emulation is the same idea of like if I run it on 4G, but it's a fiber connection at the server farm, it's backing it up as best it can, not necessarily as real world. Cool.
Awesome.
All right.
Thanks for fielding all those questions, Grayson.
Sure. All right. I'm going to jump into scripts, right? So let me see if I can find this picture here. One second. This is one of my favorite development memes and it is super relevant, right? So here we've got our server-side rendering, our bundle splitting, our tree shaking, compilers, no JavaScript frameworks. And then here's Google Tag Manager just blowing it all away, right? Like I have seen this real world time and time again, and I can't overstate it enough. There is a ceiling that's going to be on each site that you build that's going to be defined by these third-party scripts. Okay. And I don't want to pick on Google Tag Manager. I mean, there's like the Twitter embed one is notoriously bad. There's a lot. I mean, there's chatbots that are really bad. There's all different ones, right? And you can build like this perfect website, and then you get to your last sprint. Marketing says, "Cool, put the script tag on there," and then boom, it goes from a 95 to a 75. Right now, this goes back to our weighing of performance and business, right? So we want to drive leads. We want our company to make money. We need our script tags on there, right? We need our retargeting script. We need the tracking scripts. We need all that if we want to make the conversions that we want to make, but we want good performance. So ultimately, you're going to have to make a human decision and say, okay, what does the script cost us? What does the script provide for us? What I like to do is at least define that ceiling for other stakeholders and say, hey, I've tested this out and the scripts that we use they cost us 20 lighthouse points. Just, it is what it is. They cost us 20 lighthouse points. What do they provide for us? Let's look at the 10 or so that we use. Let's kind of mini audit them. Let's talk about them. Do we still need each one? And then make a determination of what we want to do. So you can think of it that way, but there will be some pushback and like, well, you're the developers, make it faster, right? So I mentioned that meta frameworks provide these abstractions over browser fundamentals, right? The script tag is lowercase script tag is a browser HTML tag, right? But teams like Next and Gatsby and others will have this abstracted script tag that you can use to kind of hopefully speed things up, change some behaviors. Let's see. And one of the main things you can do is with timing, right? So often script tags will be blocking, right? If just imagine like somebody in front of you and they're blocking the way and saying, you can't go past until I've done what I need to do. You can be like, well, actually the person behind you is more important. So can we put them in front of you and then you can block, right? So What you don't want is these scripts to be blocking things that the user needs to see the site, right? That the performance tools need to register the site as loading. So if anything is blocking, like web page test will put a little orange X by it, I know that, hey, I got to look at this. I cannot have blocking before the LCP if I can help it. So I would like to have it after LCP. There's a couple of different options, but timing is kind of like the first tool that you have with these script tags of deciding when should this script tag load. But the lowercase, HTML script tag doesn't give you that option. There's no time attribute of that element. So we have to kind of abstract around that. So if we look at, I'm going to just do the Gatsby one, but it's very, very similar with Next.js. We have this prop called strategy, right? So the default strategy here is called post hydrate. And again, this is like in a React world. I'm not as familiar with, Solid or Vue or some of these other ones, but similar ideas. So post hydrate is going to be the script tag default. And this hydrate that it's mentioning is React hydration. So I'm telling the script, do not fire until React has hydrated, right? We often want React to hydrate first, right? Like that's important for the page being loaded and the user being able to interact with the page. So this would be the kind of first chance we have to do it. This would still be later than the default, right? If you just had a script tag on there, it would execute whenever it was in order of the markup. This happens to be in the bottom after the body tag. I could put it ahead, but it'd be the same thing with the script tag. Idle would say, yes, I want you to wait till after hydration, but I also want you to wait until the CPU is idle or the thread is idle and ready to run you, right? So post hydrate is going to kind of like jam it in there right after hydration. Idle is going to say, all right, hydration's ended. Tell me when you're done working, and then you can go. So this is even a little bit more aggressive for deferring the script. And then the kind of most experimental strategy that we have, this is same in Next. I think they call it just Party Town. I can't remember what it's called on the Next script, but off main thread would say, hey, the problem is that there's only one thread for all this JavaScript to execute. I like to think about like a 1-lane bridge, and only one thing can pass at a time. We need more lanes, right? And so off main thread as this uses this tool called Party Town that runs other JavaScript in a service worker. Super cool. Still a bit experimental and a bit temperamental, I find, with some third-party scripts. They're not necessarily built to run in a service worker. There's some other caveats there. You don't want to put scripts on the service worker that touch the DOM a lot, because that service worker to DOM communication actually has like a pretty bad bottleneck as well. Like I used this once for a reviews widget, right? Or not a widget, but like it was an e-commerce site. You could just give the stars and reviews for each product. And this script would take the product ID, load the number of stars, and then render the stars into the div where they're supposed to go. And that was actually slower than just putting the script in the main thread, because writing to the DOM on these pages was so much slower. So there's sometimes where it's not as good, but it is really fast for some other use cases. So, and you can even see this, like if I got my cool demo site here, and I open up, let me do this one. This one's already built. And I open my console, like I can see I actually have this React log is happening inside some JSX, inside the template. Find it here, pages, index, right? Inside here, it's just logging as the page hydrates. Next, we'll see the post hydrate call and then the idle call. So you can tell they're happening kind of after each other. In this simplified demo, they're going to be super close together anyways. But in the real world, this can be like somewhat significant, time differences between these things running. So script tag, you're going to want to definitely audit your third-party scripts and then investigate different strategies for loading those. I'm a big fan of, like, if you have to change vendors, like I'm not going to name any analytics tools, but there's some analytics tools that are like just for no good reason, very, very heavy. And they have competitors that are very, very slim. And most of these tools, if you do a little bit of extra research, you can probably find some kind of competitor that's more focused on performance. And that can save you more time than you could ever save yourself by, all these kinds of strategies and timings and whatever. You just find a better library, get rid of the library. That's your best bet. So, yeah, that is script tags. Now you want to check any script questions before I jump onto first party JavaScript?
Yes, we have a question here from Roger. Which of these script strategies should be used for go-to-market, knowing that go-to-market then loads a lot of marketing, tracking, conversion tracking scripts in turn?
I'm guessing go-to-market is I've not heard of that. My guess is it's something like Google Tag Manager, where Google Tag Manager is one tag and then brings over however many you've set up in like your configuration in the back end, told Google Tag Manager, hey, load Facebook and Twitter and all these things. I like to at least do it post hydrate. That's kind of like my step one for teams, because there is, a consideration here with timing. Depending on what library you're trying to use and what its purpose is, loading it too late is possible. Less so than it used to be. I'd say, like, 5-10 years ago, you saw so many things were like, oh, this has to go in the head and this has to load before anything else on the page loads. That's less and less common now, but technically there could be things that for whatever reason you actually want to load sooner for a smooth user experience, or for the script to work the way it needs to work. Even Google Analytics, I think, used to be that way, right? Where Google Analytics needed to be the first thing that loads so that it could record the user's experience. Now you don't have to do that because the browser, I believe, saves those numbers, and then like later it will, collect them and send them, and it doesn't have to actually record from the beginning. But, technically there could be something where you need it really early. Otherwise, I'd start with something like post React hydration, and then see kind of how much further you can push it in time.
Awesome. We have another question here. What are your thoughts on using pre-rendering / caching services such as prerender.io to improve Lighthouse scores?
I'm not familiar with prerender.io, but SSG, I would call SSG pre-rendering, right? It's pre-rendering at a large scale where you're pre-rendering every page on your site. So I'm not familiar with that, but having a good CDN and having the right caching headers and all that set up is important, no matter whether you're using SSG, SSR, or whatever. So I'm not familiar with pre-render, so I don't want to give an answer there, but.
Fair. We also have a question here from Lev. Can't we use async / defer?
Yeah, you can add async or defer to these tags. Again, it's the same kind of idea with timing, and just making sure you understand when does the script need to load. So if you see a script that's blocking, and actually I'm not sure if under the hood, let's see. This is just the types. Yeah, I'd have to look at the source code for the script tag. I'm not sure how it handles defer and async out of the box, and what the values for those attributes are. But yes, you can use combinations of those things. This is just specifically made for React, in the sense, with the post hydrate, and then there's like request idle callback, I think, used for idle. So you could do this stuff on your own, but typically the idea of these meta framework is we battle test it so you can just use it in one line instead of, trying to recreate it yourself.
Sweet. One last question before I let you continue, Grayson. Do these script components delay loading, parsing, or execution of scripts?
Yes. Like that's the point. As far as actually downloading, I cannot remember enough about the browser behavior, whether this actually slows the network request for the script. I guess we can look. Let's look. See what we can see. Network. And let's filter by JS. Or fetch XHR. Disable cache. Oh, I don't know why I don't even see them loading. Oh, there it is. Bootstrap.min. Yeah, so you can see them. This is sorted by time. So here's the initial network request. Like you can see, I've got bootstrap.min. This is the actual script tag version I have. Let's see, 5.2.1. I had to do different versions of these so that they would like down. If I did one version for all 3 script tags, it wouldn't work, right? It only download it once. I had one, I just deleted it, that was 5.2.1 that was using a lowercase script tag. And you can see how, like, look, it's at the top, right? That's our lowercase script tag. And then down here, we've got our other ones. We've got our post hydrate, and then our idle. And then lastly, we have our off main thread. Oh, the off main thread doesn't work. I didn't finish setting up the off main thread. It needs a little more configuration, but in general, the timing is still the same, right? It's down at the very bottom, very last. And one more note on this, like these are all using the same domain. And this is kind of important. They're all using this Cloudflare CDN, right? If we look at the first request, you see the green and the orange and the purple, right? That's our browser connecting to this third-party domain for the first time, right? When your browser connects to a third-party domain, it's got to do a couple of things. It's got to look up the DNS, it's got to connect, and it's got to do like a little handshake to say like, hey, are you safe? Are you safe to talk to and receive assets from? And that can take some time. In this case, it's about 100 milliseconds or so. It's normally lower, right? But we can see this is happening on the first request. If I go down to the second one, it does not need to do that, right? It's just downloading the assets. There's no connection or whatever. So there's some strategies you can use of saying like, hey, I know I'm going to have to connect to this domain. I want to pre-connect. You can preload. Like there's lots of different strategies, but just an important call out. So this backs up what we said. So yes, I believe it is actually delaying the downloading of the like the network downloading of the JavaScript, much less the parsing and execution. I knew it would delay that, but it does seem to be doing the downloading in that order as well. So good question. That's interesting.
Also, Grayson, I lied. I'm going to ask you one more question that just came in from James. Can you use Gatsby script component outside of a Gatsby meta framework? Like, is it agnostic of framework?
No, it's not. It is part of the core, just like the Next.js script component has to be used within Next. I don't know the other meta framework. Like, I think Remix calls it something else, and Remix kind of works differently than those two. But most meta frameworks, you'll find something like it within, and they'll have really similar APIs too. All right. So we just spent like 10 minutes bashing third-party scripts and marketing and all of that. But a lot of times we're at fault too, right? That Bootstrap, like I'm using Bootstrap, but this isn't really what we would do here. Say we'd have like, GTM, right? Is the one we mainly said. We'd have GTM there, but a lot of times these scripts we're actually importing. So if we were to go to like our index page, right, I might say like import, heavy lib, right, from cool dev library, where it's the hot new thing and it makes our carousel look great, and I did it, right? Marketing didn't do this. This isn't a third-party script. This isn't Twitter's code or Facebook's code. This is our code. So I call this first party JavaScript versus third party JavaScript. Actually, this would be second party JavaScript because it's JavaScript that we're kind of integrating with our functionality. First party JavaScript would be like actually in here, like a bad loop that I write would be first party. So the second party JavaScript is often just as bad. So what can we do about it? Well, we can always be informed about what our dependencies are and why we're bringing them in. It's very tempting. The JavaScript, especially the React ecosystem, is so rich, and you're like, oh, wow, there's a widget for everything. That's great. But we should just, keep in mind the cost that it might have. But that's often difficult because we can't really visualize our problem. So let's say, this is my site here, and I've got my network tab, and like maybe we keep our eye on the app bundle, and my app bundle looks great right now. So my app bundle would be this, I would call our app bundle like our mixing together of our first and second party code, right? Yeah, Moment.js, good example, right? You want to work with dates easier, and you bring in Moment.js, okay? Which I can't remember how big it is, but it's pretty big. So you might assign a threshold here and say, all right, this can't get over 100 kilobytes, so we're going to have to do some work. But that's kind of the most that someone will look at it. There are tools, though, to visualize this. So the most common one is Webpack Bundle Analyzer, where it will take that bundle and like put in a bunch of colorful squares, and you can say, oh, wow, look what's in there, and kind of investigate from there. But a tool that I like, this is Gatsby specific, but I think it could be reworked to work with anything, is a tool called Gatsby plugin perf budgets, which kind of takes the same, I think it's just JSON that the bundle analyzer creates, and it gives you like a per route table. So it says, okay, this is the index route. This is my homepage route, and here's all the different bundles on it and what they're made up of, right? So I've got my framework bundle. This is just React, right? So React comes in at 44 kilobytes for React and React DOM. So I'll get rid of framework because I can't control that. I'll get rid of Webpack runtime because I can't control that. But now here I've got my app bundle. So my app bundle is going to be like all my code. And then lastly, I'll have like my page bundle, right? So if I get rid of this, now here's my page bundle. So here's my actual layout component. That's 2 kilobytes, right? There are times where I can visualize like, oh, this SEO component is massive. Like, why is it massive? It's not in this case. It's only 300 bytes, but this is where I can often visualize problems. If I go back to the page list, I see here I've got this lazy page, and the page bundle for that is 30 kilobytes. So I'm like, whoa, why is this 30 kilobytes? And so this is what perf budgets does that regular bundle analyzer doesn't. And it gives you a breakdown by route, right? Because if I just have a bunch of colorful boxes, it's really hard to tell, like, well, where is that bundle actually used, right? So if I click on this lazy page, I'll clear these and just do the page bundle. I'm like, okay, I've got 2 bundles here. And look what's making up the 30 kilobyte. I've got jQuery on this page, right? So that can kind of lead to our next couple of slides, but you just always have to be mindful of the imports that you're making into your code, right? And what it's providing for you. So same ideas like marketers and third-party scripts and making money and slowing down performance. Same idea is like we often look at it as like developer experience and developer speed, where it's like, I don't want to build my own carousel. I don't want to manipulate my own dates, right? Well, what does that mean for your performance and for maintenance and for all these other things, readability and all these things, right? But just important to kind of stay up to date as a team. Moment's a great example. You can probably do what you want to do with Moment with new browser date APIs, right? There's constantly new things coming out that are going to be more performance focused. So that's really all that you can do there is monitor and try to fix those things. Now, there are a lot of bundler implications here where like, how is the app bundle for Gatsby made? How is it made for Next.js? How do these meta frameworks decide what goes into what bundle? So I can't get into all that here because it's encompasses a lot. But my rule of thumb for that is most of these frameworks are trying to tell what are you trying to use everywhere. So global state management is probably the number one culprit here of if you have a Redux store wrapping your whole app and you're importing something into that Redux store, you're telling your meta framework you need that import available everywhere. So it'll probably put it in like a global bundle. And then there's new things coming out with, React server components to help with this a lot. Say there's a library that you don't need during client side, you just need it to render the markup, and then you don't need it anymore. Markdown is a great example. Say you're using a markdown library to render some markup. You just want to have that happen on server side. You don't need it anymore once it's in the browser. So please don't bring that markdown parsing library into the browser. Use it on the server, leave it behind, right? So there's lots of new strategies coming for improving this stuff. Cool. Good bundle size, really hard to tell. All JavaScript is not created equal. So you have 1 kilobyte of JavaScript can be worse for your performance than 100 kilobytes of JavaScript. If you just write like that 1 kilobyte is a 10x nested loop, that's going to take a long time. Where if the 100 kilobyte is very efficient code, the browser can parse that way faster. And execute it way faster. So size is not always the best indicator for performance when it comes to JavaScript. There's other tools I would use to look at like long tasks. So you'll see you can see like CPU usage and web page tests are in the performance tab of where did we go? Like in the performance tab here. You can profile your JavaScript here. You probably want to slow it down and do a 4G connection and lower your CPU power and stuff so that it's more evident. But because you can see here it's loading it all super fast. But you're gonna want to actually profile JavaScript in here and not just judge it off of the size. Cool. Any questions on that before I jump over to images?
We have a question here from Mohit. How to optimize moment time zone lib to reduce bundle size of a page?
So it has been a while since I've used Moment. I do know that like Moment time zone makes me think that's one of the like most like one of the realest reasons for needing it is when you're trying to serve stuff in different time zones. But yeah, I mean, built-in data object is kind of where I go first thing. Can't remember the name of the exact API, but it lets you do like the human readable thing and lots of cool things with dates. Yeah, I don't have a great solution for when you just need a bunch of time zones.
Seems like Lawrence agrees. He also mentioned learn to use the built-in data object.
Yeah. Yeah, INTL. That's right. Yeah. And there's different functions that are built off of it, but I can't remember their names off the top of my head. But
cool. I think
those will be your friend.
I think we're good to continue, Grayson.
Great. So images, right? Like you'll often see folks kind of post screenshots on Twitter of like, look, I got 100 on my Lighthouse, and either they don't link the page or the page they link to looks like this slide, right? And you're like, okay, that's great. That's the baseline is 100, but we know that real sites, your clients are going to ask for, to take them to the moon and back with as far as, the visual appeal and functionality and all these things, right? So we got Ricky Bobby here, right? If you're not first, you're last, and it's a lot of sites just start out with the big hero image up above, right? So how does your framework or how does your team handle images? That's often one of the biggest bottlenecks that I see and where people make the most mistakes. So images are very similar to dates in the sense that the browser has like a lot of good solutions, but some folks don't know about some of the new things that you can do. Also, I think images are tough because like the best practices that the browser really wants you to do involve like picture tag and the source set and all this stuff that if you're trying to do this by hand, good luck recreating that time and time again every time you have a project to get the images just right. There are a lot of good solutions for images within meta frameworks. And then actually a teammate, Matt Kane, is working on like a framework agnostic image. You've got image CDNs. They can do a great job serving up, the different sizes that are required. So there's lots of tools out there for doing this the right way. So I do not recommend trying to just like render an image tag on your own. You're probably going to pay for it performance-wise. But just to illustrate kind of the difference here, this is where's my layout template? Here it is, right? So for this, Ricky Bobby, we are using WebP. Great. Like talking about image formats is a whole topic, right? But WebP is considered one of the better ones. AVIF is probably the best quality to size ratio, but there are some downsides with it, especially for SSR and SSG, trying to transform those with Node. But WebP is great. But right here, I've just got this image tag, and there's some downsides here. Like I'm not giving the browser any hints of how important this image is. I'm not telling it what size. I'm controlling the size with CSS purely, right? So if I were to look at this element, I mean, I'm just getting my image tag here. It's actually loading, I think, a 3,000 pixel wide image. But if I comment this out, I'm going to switch to Gatsby image, like kind of the simplest version of Gatsby image here, and I'm going to run a clean build and serve. We're gonna change it up a little bit. So Gatsby image is going to do some of the work for you. You just render the one component, and it renders like the image tag, the picture. It's got the source set, the sizes, all that set up for you to render correctly for different devices, and you don't really have to handle it. I'm also telling it to render an AVIF version of the image that I just mentioned, so it's going to be a better image format. And I'm also doing one other trick of this loading equals eager. Now, this is actually an image tag attribute, right? It's just getting passed through our component straight onto the image tag. But this is where we're telling the browser, hey, this is a hero image and it's above the fold, and I actually don't want you to lazy load it. So often we think of lazy loading as make it faster by lazy loading it. That's really not always the case, right? If we lazy loaded the whole page, we'd be just client-side rendering it, and we'd have a big spinner, and we'd have all our performance problems back. We want to be selective. The question earlier about when do we server-side render and when do we client-side render, like this is what I'm talking about, of trying to be like human aware of the page and say, okay, well, I know as a human that this hero image is above the fold and it's important. I want to load it eagerly to improve my largest contentful paint. Right? If I just treat it like every other image and tell the browser to treat it like every other image, then it will go slower. So we've got our server going. I'm gonna refresh. All right, so now let's look at our image tag here. All right, so you can see we've got our picture tag. We've got our source with our source set that's based off of different widths. It's an AVIF file. So we're probably around here. So you can see we're getting a 1900 pixel wide version of this image. We've got our loading equals eager. It's a much more robust image here. Now let me see. I did not catch the sizes. It's actually still a very large image in my opinion. I think it's because I'm doing quality equals 95. So that's pretty high quality. Default, I think, is 50 or 70, something like that. So I've got this cranked up pretty high. If you lower the quality down, it will lower the file size. But in general, this is a much more robust and more performant image. But I think the biggest trick people don't really know is this loading attribute, which can be used on any image tag. And this idea of loading equals lazy is not always the best. Cool. Videos in Hero. Videos are tough in a sense. There's a lot of cool tools that let you do animations. Rive is one. I'll put that in the chat. It lets you do animations. I think Lottie is another one where they aren't really videos. They're more like animations, but I've seen really good performance with those. You can do videos. One of my favorite tricks with videos is to have like a set timeout where if for whatever reason the video hasn't started loading or hasn't loaded within, 750 milliseconds, then just fall back to an image, right? You might want to only give the video to the most, robust connections and experiences. And then for other ones, you can have a fallback so that it doesn't, give the person on their phone, a terrible experience. But video is kind of same idea. There's some tools out there like Brightcove and React Player and some of these things that have all the settings already set up for you. I would not just throw a video element in there necessarily. It goes back to our second party code question of how much help do we need and do we want to do. All right. Lazy loading and loadable. We got like 3 minutes left. I have lunch next, so I'm going to stay on until all our questions are answered, but I do want to get through these slides. So I mentioned lazy loading, right? Lazy loading is this idea of, it's basically client-side rendering, right? Like we call it lazy loading, but it's basically just letting the browser do the work and do it like after the page is loaded, right? There are totally times where you want to do this. Gatsby image by default does this. I believe Next Image does too. Of like, it doesn't start loading the image until you come within a couple hundred pixels of the image, and then it will start to load it. That's great. Thanks, Sam. Yes, I am getting some sleep out of my eyes. So there are definitely use cases for lazy loading. Another example would be, say you have some functionality that doesn't happen until you click a button. So say if they say this examples button for whatever reason opens up a modal that requires this third-party library that's very expensive, right? I don't want to load that on page load if no one's clicked the button, right? So lazy loading would be like, I want, when I click the button, then load the library when the modal starts to load, something like that. So lazy loading absolutely has a place. But I often see teams where like they come in with loadable components or React.lazy and every component is wrapped in it because maybe they were having some kind of, rendering bug where like, oh, Windows not defined. I need to, if I put it in, if I lazy load it, that error goes away. Yeah, maybe it does, but you've now hurt the performance of your page. And so you'll notice these sites, they like get super janky where it's like, all right, it's kind of just a white screen when it loads, and then the hero's in, and then the thing below it is in, and then the thing above that comes in, right? Those are probably lazy loaded components, and it hurts with layout shift, it hurts with performance. So I don't recommend it as just using it as a catch-all for all of your components. Now, I do want to talk about lazy loading within the React ecosystem lately, right? So often you would use loadable components or React Lazy or one of these libraries to do this. But React has a cool new feature for React 18 that kind of accomplishes this on its own. Now, it is not one for one. It's a little bit different. So I do want to kind of illustrate that. But let's go to we had this lazy page, right? And it's got our expensive component coming in. It's got it's got jQuery as a dependency, right? And I don't like the fact that this is, polluting the bundle size for me, and I want to lazy load this component, right? Again, contrived example. Let's forget about why I want to lazy load this, but I want to lazy load it. So what can I do? I could do loadable components where I'll change my import to a function called loadable that itself takes a function that returns an import. Right? A bit of a mouthful, but it looks like this, right? We've changed it from an import to a variable that's a function that takes a function that returns an import, okay? Great. Now it's lazy loaded. It's client-side rendered. It's also going to be code split, right? So there's kind of two two aspects to this. One is code splitting, where it's now Webpack or whatever your bundler is. When it sees this, it's going to say, oh, this does not get bundled the way it normally would. We're going to make this its own bundle. So this would make like its own little bundle called, expensive. And, then it's got some kind of hash, right? .js, right? You've all seen file names that look like this, right? So it's going to do that. That's benefit or feature number one. And then the other one is going to be lazy loading, right? And that means it's going to not SSR, only CSR. Okay. Now this is with loadable. But one of the cool new things that's happening right now is React has its own way of doing this now. And it's just called react.lazy, right? So it's going to look very, very similar to this, except instead of loadable, it's going to be react.lazy, right? Or you could do it this way, destructure the import and just say lazy, right? Up to you. Now, I believe it's going to be like a framework by framework effort for how this is code split. But this has one other feature to it, right? So if we take, it's got these two. Yes, it's got these two. But the lazy loading here is kind of got an asterisk because it's now going to be using the suspense architecture. So suspense is introduced in React 18 that it's really built for data fetching. But in this case, it also works for these imports. So for this to work, I would have to wrap this in a suspense boundary, right? And I would get the same-ish behavior as if I were using loadable. There are some caveats because you're within the suspense architecture. If you're doing certain things inside of here, it can cause re-render. So I would still categorize this as a bit experimental until there's better documentation from the React team and different meta frameworks of like, hey, here's how it behaves in these different scenarios. If you're setting state inside of a component that's using react.lazy, what happens, right? But you will still get the code splitting for sure. So the most common time you're going to want this, like in this case, I've kind of got this one random component, but most likely what you're going to have, back all this out, is you're going to have a flex page, right? A flex page is when you have a headless architecture and you've got your CMS and you're like, hey, the editor wants to make a new page. They want to order all the components the way they want to order them. So they pick a header, then they pick a banner, then they put a form in there, then they put a bio, right? And then they've got another instance of a flex page where there's no header. It's just a bio and then a form. And then, right, they're just like picking and choosing and building these pages in the headless CMS, which is great. Except when you have a template for that, right? We'll just call this lazy flex page, right? Because we need to account for whatever component they might choose. That means we need to have like every component in our library, listed out here, right? Because we'll have something like this. It's like components.map component, right? This is the list of components that they've given us from the CMS. And we want to return basically, component dot type, right? I'm pseudocoding this, but to get the idea, if the type equals hero, then render the hero component. If the type equals expensive, then render the expensive component. The problem is this is import driven. These bundlers are import driven. So we've got all these imports here. It doesn't care if we render them or not. We've told it to import it. It's importing it. So that bundle for this page is going to get really big, really fast because we're using all of these components as imports. If we were to change all of this to lazy load or to loadable or react.lazy, then they would all be code split out and only loaded if they're used. So, that's the most common use case where you're actually going to save a lot of kilobytes. But yeah, that's lazy loading. I hope that was somewhat understandable. Yeah. CMS-driven pages. That's what I mean by flex pages. And then chat widgets would be another one. We could handle that other ways too, but where you don't want to load that necessarily right when the page loads, you can load it later. Cool. Performance challenges right now. Performance challenges right now for me are more about like the conversations, right? There's a lot of cool new architectural things out there. When I say architectural things, what I mean is we've been talking about SSG and SSR and client-side rendering, but there's like these new ones, you know, the edge. You probably heard the edge. I hope I never hear the term the edge again, but the edge, you know, edge functions and all this stuff like that. That is out there. Is like there's going to be other architectures available for rendering stuff, especially very dynamic stuff very quickly, right? We haven't talked about, well, what about, you know, the idea of the edges moving at the point where it's rendered, you know, closer to the end user. We do have clients, you know, in like Oceania that like notoriously have slower time to first byte because someone's probably using US East as their data center and they're trying to render it in Australia. And like, there's just the speed of light, like, sorry, it's just going to take a little bit longer to get there. So there is the idea of like geographically moving it closer. And then even within the frameworks, you know, we haven't talked about hydration versus like reactivity and signals and all this stuff. I typically tell teams, don't worry about that, right? Like odds are somebody above you made your tech stack decision of whatever framework you're using. Just go into it, focus on the fundamentals, build the site, you know, as best you can, and don't try to get too into the weeds of like how these different frameworks actually, you know, work with the browser. If you're curious, like by all means, go learn it. But odds are your site isn't slow because it is using React with hydration versus using, you know, signals and reactivity. Like if you're at that level of needing to worry about performance, then probably nothing that I've said today even like applies to you, right? You're just at, you know, you have virtual list of 100,000 items with multiple columns and tables, and you need, you know, running like big financial software, you know, something like that. Like then maybe if you want to get into the weeds on those conversations, go ahead. My big struggle is teams kind of leading with those questions and being like, look, you're rendering your image tag wrong. Like, you know, I don't care what your front end framework is if you have, you know, 3 megabytes of third-party JavaScript. Like it just is not relevant. So setting the discourse to focus on fundamentals first is the biggest struggle I have. Cool. And that's all I've got for slides. So if we got any more questions, I'm happy to round those up.
Thanks, Grayson. Folks, I know we're nearly 10 minutes over, so if you have to go, totally understand. This recording of our office hour with Grayson will be uploaded onto YouTube. So keep your eyes peeled on Netlify's YouTube channel for this. But for anyone that wants to stay, I will be asking Grayson a couple more questions, and then we're going to bounce because I do want to ensure that he gets some lunch in before the rest of his day. So Grayson, let's see, what new questions are we getting in? Okay, we have a question here from Ben. How are you handling performance when doing A/B testing, client side or server side?
Great question. So this is where I think like the discourse is moving towards things that are very dynamic, right? A/B testing is probably like just the very first step towards like dynamism of, all right, we want, you know, users on the West Coast to get version B and users on the East Coast to get version A, right? That means you need 2 versions of the site. Doing that client side is going to hurt performance. Doing that with the static site generator is tough because then you have to render 2 completely different versions of the site, which can have build time implications. So that's where you have things like the edge and you know, good SSR implementations that can make that better. So I would say SSR if you can. It kind of depends on your tool and your architecture as to the best way or the best possible way that you can do that. But yeah, I would recommend doing it server side as much as possible.
Cool. We have a question here from Paul. What about adjusting images for devices with higher device pixel ratio, like providing higher resolution version for people using iPads with Retina displays?
Yeah, it's a good question. So Gatsby image by default does size, like window size based. You can generate multiple resolutions of an image instead. That's not the default behavior. And I still think it measures based off of the window size. So I don't think it actually looks at the device resolution to decide what resolution image to serve up. But that's a good question. I'm not sure of a solution that uses that as kind of the baseline of which image to serve. But that's a good question.
If we're lazy loading components, don't we lose out on the SEO benefits since we're client-side rendering instead of server-side rendering? Is there a way to easily code split components without the CSR?
Yes. So a big like asterisk that I kind of missed on this lazy loading is that you want to make sure with when we're doing this code splitting, right? A lot of times we want to code split, but we don't actually want to lazy load. We still want to SSR. So like for Gatsby, there's a plugin for loadable in general. They give you a strategy. Loadable components is what I'm referring to, by the way, when I keep saying loadable components. It's like the React 17 and down recommended way from the React team for code splitting. And they have an SSR guide of like how to use loadable components, but maintain SSR because you want to maintain SSR for SEO purposes. Now, the big reason like React.lazy existed before React 18, but before React 18, it would not server-side render. So you could use React.lazy, but it would client-side render. Now with React 18, you can use React.lazy and it'll maintain SSR. So I see teams all the time. They'll use loadable components, but they'll either not use the Gatsby plugin, or if they're using Next, they won't follow the Webpack guide and Babel guide for like how to maintain SSR with loadable components. And yes, then they're losing SSO, they're losing performance. So you do not want to implement this without ensuring that you're getting server-side rendering still happening. Great point.
We have a question here from Noor. Can intersection help to not render the component and benefit on page load speed? Is that something you've tried?
Yep. So like these image plugins, the Next Image and Gatsby Image, they're using Intersection Observer under the hood, right? That's one of those things where if you wanted to implement that on your own, it'd probably be a fair amount of work. So that's what they use under the hood to determine whether that element is about to scroll into view and whether to start loading it. So yeah, Intersection Observer is great.
Okay, we're going to end it with one final question, folks. Have you started hearing more about other performance benefits like reducing website carbon emissions?
Oh, that's a great question. I know that I have heard of tools that will measure that for you, but I don't know enough about like the best way to measure it. I've thought about it before, and I'm like, okay, I think that SSG is probably the most energy efficient because you don't have a long running server. You just have basically 1-to-1. So for every page, you get one render. Right. In your build server, it builds each page. So like that server is up, it builds a site, that server is gone. Then you have a CDN, right? So obviously your CDN has to run some stuff. Whereas purely SSR, maybe you have serverless functions that are spinning up and down to render those, or you have a long running node server for handling SSR, but it may be long running, but maybe you don't get that many page visits on certain pages. And so if you have 1,000 pages, only 100 are getting visits that month, and therefore you have less render somehow. I'm not sure exactly how it works out and how they run the math on those tools, but I have heard about them. But I haven't dug too much into the methodology of how they determine whether a site is more or less energy efficient.
Well, folks, I think that just about wraps it up. Thank you so much for joining us all today. I know we've gone 15 minutes over time and we're still getting a whole bunch of questions, Grayson. So not to put you on the spot, but I think we might have to do a part 2 for folks so they can get the rest of them answered. But for everyone still hanging out with us, if you would like to work with Grayson or one of our other professional services engineers, please drop a line in the chat and someone from our team will be in touch with you. And for folks who want to pass over this recording to their teammates, we will be uploading it onto YouTube shortly on Netlify's YouTube channel. So be sure to keep your eyes peeled on that. Thanks again, folks, for joining us. And thank you, Grayson, for fielding, I think, got like over 25 questions. I lost track after that, honestly. So thanks, everyone, and we'll catch you soon.
Cool. Thanks, y'all.